Hi there. I'm Kendra Lord, Director of Geospatial Engineering and Analytics from T-Mobile's High-Speed Internet. I'm here with my colleague, the bearded wonder, Ryan Rembert, our Director of Software Development. Well, it's either him or some other random bearded guy from Seattle. Either way, we're excited to be here. Leveraging spatial data in telecom is such a big topic. It's frankly something we could dig into over a period of hours. However, we're going to focus on one of the largest challenges we've had to try to tackle, and really early on when we're launching this business. When you go to any ISP's website to try to get your new internet connection, the first thing you're met with is the question, can we serve you? Qualification is the first entry into any ISP's customer journey. So today we'll focus on qualification and just how we are solving that by leveraging spatial data science. I will address just how we're using Carto to solve the challenge of qualification, and then Ryan will share his complexities around data loads and building a spatial-driven analytics tool. So what's the big deal? Location matters in any internet service provider. However, traditional ISPs are qualifying based on a fixed location, leveraging fixed infrastructure and resources. When serving an ISP over a non-fixed network, that requires an entirely different qualification process, one that involves a large amount of spatial data. We've built a solution that heavily leverages Carto, both in processing and visualization. To first size the problem, it's important to understand how traditional ISPs approach. Qualification of service is determined by proximity to the resource and infrastructure, which is typically based on the proximity to the last mile delivered over cable. A wireless network creates an entirely different set of considerations. When serving internet over a non-fixed network, the key to a good experience is consistent and quality connection. A household receiving a quality connection can be miles from a cell tower. In rural areas in particular, this method of service has incredible advantages. Customers in these areas are frequently in the ISP equivalent of being between a rock and a hard place, because the return of investment just doesn't make sense for a traditional cable provider to serve that area. The customer is forced to either pay for a premium for slow connection or depend entirely on satellite. If you know anything about satellite, customers don't love it. You get a slow connection, you get inconsistent service, and you pay a premium for both that service and the hardware. A large part of our mission is to serve those customers. And in order to answer the question of who we can serve, geospatial network teams calculate the capacity for delivering a consistent internet experience by analyzing the propagation of radio frequency to households within the cell site's coverage footprint. This presents interesting spatial challenges. For example, predicting the expected experience of a home internet customer by accounting for terrain and foliage interference from a tower, or where a device must be positioned in their home. For that matter, what their home material is constructed of. These are all questions that our teams focus on to allow us informed determination of possible regarding qualification for service. And of course, they're not novel challenges for us to solve. When you walk into a T-Mobile retail store to start a cell phone plan, no one cares what your house is made of or how far it is from the nearest cell tower. Now, this is the part that's really interesting to me and my team. There are about 185 million unique addresses in the United States, each with untold variables associated with them. How can we make sweeping determinations of who is qualified for service? Or at an aggregate level, which zip codes, MSAs, or states have the greatest potential? There are a number of intermediary challenges here that many of you, whether GIS analysts or data scientists, are familiar with. These include handling the massive size of parcel polygons, identifying unit coordinates within a larger building, and of course, managing large amounts of data. There's one in particular that I want to focus on though, and that is how we analyze service qualification at scale using spatial indexing and Carto. Trust me when I say there are people on my team that would like for my entire chat here to be about the wonders of spatial indexing. If you aren't familiar with the concept, the idea is that it does not make spatial sense to compare non-uniformly shaped polygons, essentially when the lines move between years or censuses. Matt Forrest from Carto has a great blog post on the subject. The solution to the problem is to use uniform shapes, such as hex bins or squares, and intersect them with a given area. This has a number of other advantages in terms of scaling that are discussed in the Uber H3 blog if you want to check it out. The way to solve big problems is by making them small. Using spatial indexing allows us to do this by taking radio frequency propagation and converting it to uniformly shaped hex bins. We use a size where we have confidence that all addresses within hex bin will see similar experience before further optimizations at the household level. Don't get me wrong, there are still millions of hex bins at this point, but it's a much more manageable number than all addresses individually. At this point, we know serving sector, we know the technology the service is being delivered, and qualification for service. By having both detailed address data and aggregate data available, we can shift between the granularity of the data that we utilize, depending on the use case. We're also able to carry out analysis with our uniformly shaped hex bins and then intersect back to zip or census block as needed for consumption by other teams. Thanks so much for your time. Now Ryan will talk about handling this data at scale.
Great, thanks Kendra. So like Kendra said, at the end of the day, we need to condense a significant amount of complex data into a form that allows like identification of competitive locations where we can actually provide a stable and consistent connection. So to this end, we developed ICA. ICA is our internal analytics platform that helps us translate spatial data into like actionable intelligence while also providing services that allow our enterprise channel sales and marketing partners to sell our products correctly. Now, when I mean correctly, I mean not only that we're selling to the right locations, but also that we can monetize or monitor enterprise systems for sales compliance. We need to feed our operational support systems, and we need to understand the performance of the product in the field to basically ground truth our service expectations during that eligibility process. So because we're not only dealing with a great volume of data, but we're also dealing with very complex once you layer in all the sales and network performance data. So very important for us to make the eligibility and sales compliance pieces as easy to understand as possible. In situations where we can't sell everywhere or we have a network, we have to make the process as simple as possible so that our agents in the field understand the product and they can accurately communicate expectations to the customer. So at its core, ICA is not just a set of architectural components and analysis tools, but it's also the methodology Kendra talked about, and it's our entire process for how we think about our product. Case in point, not enough for us to understand where we can sell. We also have to consider like how we handle transitive traffic. We're a mobile network, right? We're optimized for people going 60 miles per hour on a highway, whereas we're a fixed location. So overselling and the risk of overselling can really affect the experience of our customer base. So now switching over to the diagram that you're looking at. Now this is a very, very, very overly generalized structure of like how ICA flows. But if you think about it, we start with our initial batch ingestment, enrichment of network data files, but we have more dynamic components downstream with APIs and UI tools that kind of interact and end up kind of producing the customer and operator facing flows and tooling that we use every day. So as we're going through this, just try to conceptualize our end-to-end flow as a ring road. It may have several on-ramps, but by providing a processing pipeline that's deterministic and idempotent, we can provide fast access to operational historical data. We can safely poke at our data at any stage without a deep understanding of the system as a whole. So the spatial indexing and network data ingestion pieces Kendra talked about, those are bounded through items 1 through 3, but trust me, there's a lot that happens before 1 that's also very complex. Steps 4 through 5, once we finish processing qualified locations, we load them into our operational data store so that our app services can perform eligibility checks against the latest set of index keys that Kendra provides. To maintain a healthy cadence for new feature development while maintaining high service uptime and availability, because at the end of the day, if our services are down, we make no sales, right? So our platform development teams heavily leverage managed data stores like Cosmos, MongoDB, Atlas, et cetera, for our persistence layer, and then things like Kubernetes for our backend services. Steps 6 through 10, this is kind of where we start getting into the sales flow. So once an eligibility check's been made, we flow both eligible and ineligible leads into our CRM and our order processing systems so that our customers can check out via digital channels or via kind of a more assisted sales channels in retail, for example. Once orders are created, the channels then update ICA, which in turn syncs data into our data warehouse, which we either report on or we feed it into the next network data ingestion cycle. So tapping into our real-time data feeds usually requires a data engineer or data scientist. However, like most businesses of our size, we have far more questions of our data than we have engineers available. So similar to most data shops, we build a network of tools on top of ICA to service our data. So the next slide, I'm going to kind of go over like one of those tools we build. In addition to the vast array of BI dashboards that I'm sure most of our businesses of our size have. So like most companies, we talk a lot about scaling growth, but from an application perspective, from a data perspective, what does that mean? And by the way, this is just my opinion, and I'm speaking solely from a data perspective, but it's actually not usually about infrastructure, and it's usually not really about customer growth. It's really about answering questions fast enough for the next set of questions come in. One of the ways in which people try to solution for this, they'll create a self-service analytics tool. Just a pro tip, if you're ever dealing with me in person, self-service analytics is a little bit of a dirty word for me. We're an emerging products group. We're doing things that haven't been done at T-Mobile before. So painting in broad strokes, self-serve works when you know what the questions are. New questions are being asked. You aren't being asked to expand into other business verticals. That's completely antithetical to like what we are as emerging products. Like no one really knows the questions we have to answer. So in this situation, if you're building a self-service application, there's no difference between that and your other application. You're going to have to adapt as things change. What you thought was self-service isn't going to be self-service in the future. So, and we have to really account for that in our tooling to account for that. So, as a guideline, we like to move fast. We don't like to dictate what tools people use. We want people to use the tools they're productive with, things that are out there in the open source community like Jupyter Notebooks, Spark, working with Cardo a lot. We work with Cardo a lot. And those are the tools that data scientists and others are very familiar with. But we have a lot of users on our application side that aren't really SQL jockeys, right? They're not really data scientists. So one of the things we build on top of that, the view you're kind of seeing here is, and I won't go into a full description of what's here, but it's effectively a data catalog and an ad hoc analysis tool for our like I said, I wouldn't say non-technical, but they are our non-data science, non-data engineer community. It's very heavily inspired by look and feel and some of the flow of things that you would see in data journalism, New York Times, Washington Post, etc. We wanted to encourage users to explore data without having to worry about, having to perform common data aggregation such as counts, schema exploration, etc. We wanted people to just kind of open the tool, start creating some projects, start creating some layers, and start to kind of create a story around their data. This is very commonly we use this tool to even present on internally. In particular, this provides a lot of utility for us, while also kind of serving Kendra and I need to kind of protect our data. Obviously, we're dealing with a lot of sensitive data in our business, but we need to be able to control how people can import, export data sets. We have some tools like being able to write custom SQL for our power users. Like I said, we create projects and workspaces. We can share those with other users so that we can kind of reuse data over time and different views for different operations team. And that's the gist of how we sort of approach this kind of like I said, I don't like to use the word self-service, but we try to create a very broad underlying surface area in which people can start exploring data. Under the hood, in terms of the stack perspective, it's built with React and various WebGL libraries, OpenGL, things like that. And on the back end, we have connections to Cardo and a number of other APIs that help us kind of analyze our data and surface either structured batch or real-time insights. So real quick, just to sum things up, with Cardo support, we've been able to build what we believe to be a creative solution to a complex industry problem, and one we believe will be able to adequate flexibility and scalability as we grow. With that, I'll open up for questions.
We actually just had a question come in on the Q&A. I'm not sure what this is asking, but how do you conflated the address data? I'm not sure what that one is getting at there, but maybe you could look in the Q&A and try to kind of figure out what that person was asking. Is it also possible to get Kendra and Ryan your contact information? It looks like there are some folks in the chat that would be interested in connecting with you after the conference as well.
Yeah, absolutely, no problem. We'll share contact information with Cardo to share out. But perhaps it's how do we convert address data is perhaps what the question is.
Let's go with that one.
We've got a couple of ways, and I think maybe Ryan wants to talk to some of the geocoder applications that we're using.
Sure. Yeah. I mean, I think as anyone who's been a part of or done any type of spatial analysis, or at least tried to do kind of matching up to address fabric, there's so many different address fabric data sets out there. So we've kind of taken the approach that we've kind of created our own composite geocoding service. So one, we want to maximize whenever people come to our website or whatever and they enter their address, we want to be able to do the best job we can of surfacing the address they expect to see back, whatever. So we have our own, we built our own kind of composite geocoding service that can take, the address streams they do, forward geocode them to a number of underlying address fabrics. So effectively what we'll do is we'll take services, so you say 123 Test Street or whatever, we will take that, we will compare it against one of the geocoders we use under the code is Mapbox. We use several others. We will take that address, we'll try to find a feature ID for that place. We have a little bit of an additional internal logic in which we sort of try to do a best match or a relevancy score against like what's the closest to where the closest to where the centroid of where we've identified a coordinate for service. And we'll surface that back to the customer. And that's basically what we use. We kind of tie that to our spatial index and try to get the best match we can. We can't get, just anyone who's worked with the address fabric data set, you can't get 100%. And for us in particular, it's especially hard because we're dealing with radio propagation waves. So it's physics at the end of the day. So it's a guess. If it's high tide versus low tide near the coast, that can affect your signal, right? So at the end of the day, we're not really striving for 100% accuracy. We're just trying to get as close to that as we can. And we get somewhere between like 97, 98% accuracy when we kind of ground truth the values after someone receives the device. So we do a pretty good job of that. But it's really hard, and obviously because the address fabric data sets change all the time, it's an evolving process to make sure we're matching address data to spatial indexes as best we can.
Absolutely. Thank you, Ryan. We have a couple of questions left, but I think we have time for one more, which I think is really interesting because you kind of spoke about how you're working with a lot of non-technical business users and kind of trying to get your more technical insights to them. So we have a question on, do you find you have difficulty advertising your product and getting people on board to use it?
I think from a business perspective, it's a challenge, particularly where we sit in the company is smack dab in between network and marketing. Network wants us to protect the network as much as possible, whereas marketing wants to go fast and sell big. So by challenging them to have a visualization capability to see this 2D data and with a 3D lens and the importance of it, particularly with our product, has kind of put us in a place where we can't scale fast enough. And I think from a business perspective, the whole of telco is likely going to have to transition to this because location historically has not mattered. Location is where we start, and it changes the customer journey, may change 5 or 6 times throughout the story. And that's going to impact how marketing interacts. That's going to impact how business leaders need to make decisions. It impacts how we determine what's our plan for the next year. So I think Ryan's team in particular has a challenge to scale very quickly, which is challenging in the COVID environment, to say the least.
And one of the other things I would know, this is 101 for us that we try to convince people. It's like, everyone, especially when you talk internet, you want to talk speed. Everything, whenever you request your internet service, it's like you're getting X number of gigabytes per second. What most people don't realize, you don't need a gigabit connection to do the things you want. So we try to help people understand the experience rather than speed, because really it's more about reliability. No one really cares about their internet until you get a spinning thing where something's buffering, right? You don't really care how fast it is. Most people don't realize, like if you're watching Netflix and like, oh, I want to watch Netflix, I need a gigabyte connection for HD. Completely false. Netflix actually throttles you at 25 megs per second. So I dare you, and by the way, I challenge everyone to take a look at that, but they will throttle you at 25 megs per second. It doesn't matter. So why are you paying for a gigabit connection when you don't actually need that to consume the services you want to? So that's kind of fighting these speed myths is a really big piece of what we're trying to convince the people. For us, it's all about, can we just provide a reliable connection? We are plenty fast enough for anything anyone wants to do. We can't support gigabyte speeds, but we can support anything you actually need to do, as long as we identify the right location and we map it to a location where, exactly where we have enough network, we have the right signal propagation, whatever, that can actually connect you reliably.
Awesome. That is a very good pro tip, Ryan, on what consumers actually need versus what we're told we need. So appreciate that. You're also speaking our language on location, not just for real estate. It can open up just such a wide array of questions and then really interesting answers. So I know there are a couple other questions in the Q&A, but we are out of time. So I'll leave that to you guys to connect with those folks and share your email, because a lot of people found your talk really interesting.
Yeah.
As did I.
Definitely ping us on Twitter, LinkedIn, whatever, email us, and we'll answer any questions you have.
Yep.
Cool. Thank you so much for your time today.
Thank you.
Thank you. Cheers.
Bye.